Hello, my name is Armando Bañuelos. I am a course developer and course facilitator for the AI professional program. I'm a Stanford alum. I graduated with a degree in computer science and a specialization in AI. Over the last 5 years, I've been working really closely with Stanford faculty and staff, along with some really amazing colleagues, to build out some of the course offerings that you see in this program. In this presentation, we'll be going through how to create a focus area within the AI program based on your background and/or interests. At a high level, the professional program differs from the graduate program. Even though they operate under the same umbrella, you can take one graduate course and count it towards a professional certificate. Otherwise, we do require 3 courses to be completed to earn the professional certificate. Our courses are adapted from the original on-campus version of the course, so we try to maintain the same level of rigor, the same content, and the same assignments, but we try to adapt it for a professional audience. In order to enroll in the program, we require a short application where we just confirm your proficiency in some of the prereqs, such as Python, calculus, linear algebra, and probability. We also have online lectures and autograders, so everything is asynchronous. You can watch the lectures on your own cadence and also submit coding assignments and get feedback from both the coding and the written parts. Each cohort is 10 weeks, and it roughly estimates to 10 to 15 hours of workload per week, even though that may fluctuate based on your background and your strengths. Learners will have a personalized remote support program. Learners have a personalized support Slack group where they can talk to their course facilitators or engage with other peers to collaborate and ideate on some of the problems from the programming and or coding assignments. The courses are pass, no pass. And so at the end of the course, once you reach the minimum number of points, you will receive a digital course completion certificate. And once you've completed 3 courses, then you'll receive the professional certificate. We have 8 different offerings and are continually exploring new additions. The content is derived from the graduate course content. So Stanford faculty still teach these courses, and the level of rigor is still the same. And we regularly talk with our faculty partners at the end of each cohort run so that we can refresh the content and keep it current. Our courses center around different branches of AI, and they can range from very theoretical to practical, and they can be grouped into different specializations. In a couple slides, we will see how we can group these specializations into tracks that can help facilitate what courses you should take next in the program. Coming up, we will go through a brief rundown of all the different course offerings that we have in the AI professional program. Starting off with XCS 221, we have the Artificial Intelligence Principles and Techniques course taught by Dorsa and Percy. The idea of this course is to give you the building blocks, terminology, and background to be successful in other courses. So you'll be covering some important foundational AI algorithms like logic, constraint satisfaction problems, Bayesian networks, just to name a few. And you'll also be covering the history of AI and ethics. The prerequisites for this course is basic linear algebra and probability. The assignments will be primarily using NumPy, and this course doesn't really dive into deep learning, so you won't be using PyTorch. There are a total of 7 assignments, 6 are required, 1 is optional, and this course is definitely ideal for those who want to refresh or looking to strengthen their foundational knowledge in AI. Next up, we have XCS 229 Machine Learning taught by Tengu and Chris. It's a very theoretical proof-based course, and the idea is to focus on building core ML algorithms from scratch using NumPy. So some of these algorithms include Gaussian kernels, principal component analysis, support vector machines, logistic regression, and neural networks. There's a heavy focus on stats and mathematical comprehension to improve debugging skills and analyze errors and like to look at the bias variance trade-offs. The ideal candidate for this course is someone who has a really strong foundation in linear algebra, probability, calculus, and stats, along with some familiarity of ML concepts, and of course, some experience with Python and NumPy. There are a total of 5 assignments. And this class is ideal for those with a really strong math background and just want to have an introduction to ML and statistical pattern recognition. Next up, we have XCS 224N, Natural Language Processing with Deep Learning. This course covers all the foundational concepts for NLP, including transformer models, LLMs, RNNs, word vectors, and NMTs. It's a mix of theory and practical. You'll be using PyTorch to build a lot of different models. And the idea is to just walk through and implement the evolution of key NLP architectures over time. The ideal candidate here has a strong knowledge of probability, linear algebra, and calculus with some familiarity in neural networks and optimization, and definitely some experience using deep learning frameworks like PyTorch, even though it's not required. We do have like PyTorch and Python tutorials for each of our courses. So if you feel like there are holes in your understanding for how to use these frameworks, we do provide the resources to be successful in those courses. There are a total of 5 assignments. This is great for learners who are looking to gain an understanding of NLP on a foundational level. Next up is XCS 234 reinforcement learning. This covers real reinforcement learning applications such as RLHF and DPO and model-free policy evaluation. There is a heavy emphasis on mathematical and statistical foundations, and there's going to be advanced coding and proof-based assignments. So you should be very proficient in probability, stats, linear algebra, and calculus, along with knowledge of optimization, neural networks, and deep learning frameworks like PyTorch. There are a total of 5 assignments, and it's a very rigorous course for learners who want to seek a strong foundation in RL, but also explore its applications and some of the theory behind it. Next up is XCS 236 Deep Generative Models, taught by Stefano. This course is all about exploring technologies behind text-to-image systems, but it's also about covering the evolution of generative models. So you start with autoregressive models, and then GANs, and then autoencoders, and then cover some of the latest state-of-the-art models like diffusion and score-based models. The course has a mixture of theory and practical applications where the assignments will be using manageable data sets. Prerequisites for this course include a solid foundation in ML, familiarity with neural networks, optimization backprop, and basic knowledge of linear algebra, probability, and calculus, and familiarity with PyTorch is also encouraged. We have a total of 4 assignments, and it's best for those who want to just deepen their understanding of generative modeling, its evolution, and its applications. Next, we have XCS 224W, Machine Learning with Graphs. It's a very hands-on practical course. It focuses on the construction of GNNs, and we use PyTorch-based Colab notebooks. So some familiarity with linear algebra and probability is expected for some derivations, but the majority of the assignments will be coding some of the algorithms discussed in lecture. And so many of the things that will be worked upon in those Google Colabs are industry application of GNNs. So some familiarity with linear algebra, probability, and basic machine learning concepts is required, along with some experience with PyTorch. It's a moderately rigorous course for individuals who want to tackle large-scale like graph analysis and focus more on data mining strategies. And it's definitely a course that you can apply very directly to industry-level applications. XCS 330 Deep Multitask and Meta Learning is a course that expands upon the XCS 234 course. It's not required to take XCS 234 reinforcement learning before this course, but a lot of the topics will be expanded upon in this course. Some of the advanced RL topics covered will be like multitask learning, meta learning, transfer learning, domain adaptation, and generalization, just to name a few. And it's a very theoretical course that uses coding assignments to just highlight some of the key concepts. So a strong foundation in probability, linear algebra, calculus, and PyTorch is recommended just to be able to keep up with some of the content in the course. There are a total of 4 assignments, and it's definitely a course for those who want to gain a really advanced understanding of deep learning concepts and reinforcement learning concepts, such as like multitask learning and meta learning in both theory and practical settings. XCS 224U, Natural Language Understanding, is a very hands-on course. And there's a project component that focuses on taking key NLP topics and applying it to an area of your choosing. And you can kind of have that project be submitted for a conference, or you can just directly take that project and take it to wherever you are currently working. And the idea here is that you'll compete in friendly bake-off competitions, where you'll be working on applied NLP topics such as contextual word representation, LLMs, few-shot learning, and information retrieval. Although it's not required to take XCS 224N to be successful in this course, a lot of the topics that are covered in XCS 224N will be expanded upon, and it's ideal to definitely take that course before this one. Familiarity with probability, linear algebra, calculus, and foundational NLP concepts is definitely encouraged, and some experience with PyTorch as well. There are a total of 3 assignments, including the original system and then one open-ended project. So this class is definitely ideal for those who want to have a hands-on, practical, project-based course focused on NLP industry applications. Next, we'll be talking about how to create your individualized path within the AI professional program. So there are some individual considerations for what courses you should take and how to take them. And some of them are like your personal and career goals. What are you trying to achieve? Your professional background. What are your skills and strengths? Are you more of a coder? Are you more of a data science type person that is like really strong in math and science and math and stats? How much time do you have on your hands, right? So if you're really busy at work, maybe you want to take a course that's less rigorous. And then, of course, your budget, like how much time and resources you're willing to invest in a particular course. We have grouped our courses into different groupings. So we have like an NLP grouping, an AI ML foundations grouping, a robotics RL grouping, a generative AI grouping, and finally like a GNN grouping. The idea here is if you are particularly interested in a subset of AI, like namely NLP, we definitely encourage you to take those courses in that grouping. Whereas if you're more interested in generative AI, then maybe taking that course in that specific grouping is something that you should probably consider as you're planning out your professional program. The first pathway is the classical ML pathway. So this pathway just gives you a really deep understanding of some of the base classical ML and AI algorithms. So you can start with XCS 221 and then transition to XCS 229, where you'll be more in the proof theory world. But from there, you can take any track of your choosing. So if you really want to branch out and explore the robotics track or the generative model track or the graph track or the NLP track, you can feel free to do that now that you have the foundations needed to be successful in all the courses. Next is the NLP pathway. The NLP pathway is for those who really want to kind of focus on creating a pathway that emphasizes natural language processing. So you can start off with XCS 221, although it's not it's not a strict pathway. So XCS 221 can be omitted if you feel like you have the foundation, the AI foundations to be successful in XCS 224N, and you can just start with the NLP course. From there, you should take the natural language understanding course, where you can just take that applied knowledge that theoretical knowledge that you've accumulated, that you've learned about in the NLP course, and apply it in the NLU setting. And on top of that, you can supplement your knowledge in NLP with a variety of different course groupings. So you can kind of go into the more theoretical route. So if you go up and take the XCS 229 course, and you can kind of explore some of the deeper underpinnings of core ML algorithms, and then transition to a lot more theoretical but applied courses like RL and deep multitask and meta learning. Or you can just kind of go down the rabbit hole of exploring the generative model side and the graph side. The robotics pathway is another pathway that helps you learn about the underpinnings of some crucial concepts for robotic type applications, namely RL. And so the idea here is you start off by building on your core foundational ML AI by taking XCS 221 and XCS 229. And from there, you can kind of dive into the RL world now that you have context for how to, work with some of the proof-based questions that we have and the coding-based questions that we have in our program. And you could also supplement the reinforcement learning classes that you take with a graph class to figure out like how you can maybe create models that combine both graph algorithms and RL algorithms in robotic type applications. Next, here are the courses ranked by the level of rigor. So rigor being the number of hours you may have to dedicate per week on a course. Normally, we advise students to spend 10 to 15 hours per week for the 10 weeks that the cohort runs, but some courses may be a little bit more rigorous depending on your background. So at the very top, we have XCS 234, Reinforcement Learning. It is both a very theoretical and hands-on course where each assignment is very hefty and so you'll be spending a lot of time coding in PyTorch, but also writing proof-based questions to have a really solid understanding of reinforcement learning. And at the very bottom of this graph is 221, where you have some exposure to theory and some exposure to programming, but both of those aren't at the same level of rigor as reinforcement learning. And kind of scattered in between these two graphs are other classes that you may want to take that are not as rigorous as the reinforcement learning class. So for instance, all the ones on that third layer that have the generative modeling course, the natural language understanding course, the graph course, and NLP course, all of them are about the same level of rigor. So you're expected to do some coding and some proof-based questions, but the level of proofs and code won't be as difficult as the ones preceding them in that diagram. Here are courses ranked from most applied to most theoretical. At the very top, we have NLU, which has a project-based component. So the idea here is that you can take that project, apply it professionally, or submit it for a conference, and you'll be definitely working a lot more in the code to be able to build out a personal project of your choice. And at the very bottom, we have machine learning, which is a very theoretical course. A lot of it will be writing proofs and really trying to understand the underpinnings of some of the core ML algorithms presented in that class. Scattered in between, we have some courses that are both theoretical and applied. So some of those include like the generative modeling course, the NLP course, and the meta learning course. The idea with this figure is to give you some perspective as to what classes you should take based on your both familiarity with math and stats, along with how comfortable you feel with programming and being more applied. Speaking of pathways for those who have a strong math, stats, or theory background, this is a really helpful pathway for those who feel like they have a really strong background in math. And the idea is to just start off with the most theoretical course, XCS 229, which will help ease your transition into the machine learning world. So you'll get some of the rigorous math that you're used to, but you'll get exposure to how it's being used in the context of machine learning. Then you can transition to XCS 221, where you have a mixture of coding and some theoretical questions. But here, the emphasis for taking that course is to just give you more exposure on the coding side, so you can ramp up your skills as to how to learn how to navigate some of the programming assignments introduced in our program. From there, you can branch off to the robotics grouping, the graphs grouping, the generative model grouping, or the NLP grouping, where you have that exposure to both the coding and the theory, so you'll be successful in any of those type of classes that you take next. This is a pathway for those who have a strong programming background. So the idea here is you start off with 221, just to get both background in the theory and the programming world. But from there, you can branch off to some of the other courses that also combine programming and theory, but in a little bit more of a rigorous setting. So that can be our generative model course, our graph course, or our NLP course. And then from there, if you really want to explore and be a little bit more rigorous on the theory side, maybe you want to branch out of your comfort zone and not just stick to for coding all the time, then you can take XCS 234, our RL courses, or the machine learning course. We've gathered together a bundle of resources that could help you in giving you a better picture of what to expect. So you can scan this QR code or find the link in the description of all the resources to help you make the best decision. If you're curious about the assignments, we have some syllabi linked there. If you want to learn more about the level of rigor of each course, you can skim the content of some of the grad assignments in the free resources section. If you want to just get a general overview, you can check out the brochure. And if you have just general questions about the program, definitely check out the AI ProEd FAQ. Thank you for taking the time to sit through this presentation. I hope this gives you more insight into how to create a custom pathway within the AI professional program. All the best.